calculate voltage drop for powering a well, several factors must be considered. These factors include the length of the wire run, the wire gauge, and the current requirement for the well pump. In this specific scenario, the wire run consists of 170 feet from the house to the well, plus 500 feet inside the well casing, totaling 670 feet. The wire gauge used is number 12. The current requirement for the well pump is assumed to be 10 amps, which is typical for a 1/2 horsepower well pump. Using a voltage drop calculator, we can estimate the voltage drop to be approximately 3.7 volts. The acceptable voltage drop for a well pump depends on the manufacturer's specifications. Generally, it should not exceed 5%. In this case, the calculated voltage drop of 3.7 volts is within the acceptable range. Based on the voltage drop calculation, there are two possible feeding options. Firstly, a 240 volts service can be used. This option will provide a stable voltage with minimal drop. However, it will require running a 3-wire circuit from the house to the well. Secondly, a 120 volts service can be used. This is a more economical option, but it will result in a slightly higher voltage drop. However, it is still within the acceptable range. Considering the distance and depth of the well, a 240 volts service is generally recommended to ensure a reliable and consistent voltage to the well pump. This will minimize voltage drop and potentially extend the lifespan of the pump. Several additional considerations are important. Firstly, the wires should be enclosed in a protective conduit to prevent damage and ensure safety. Secondly, proper grounding is crucial for safety and should be implemented according to electrical codes. Thirdly, install a circuit breaker at the house to protect the circuit from overloads. Voltage drop is a reduction in voltage in an electrical circuit. It is caused by the impedance of the conductors and the current flowing through them. Excessive voltage drop can cause equipment to malfunction, overheat, or fail prematurely. Voltage drop is an important consideration in electrical design because it can affect the performance and safety of electrical equipment. There are several factors that affect voltage drop, including the length of the wire gauge, the current flowing through the wire, the type of wire, and the temperature of the wire. The longer the wire, the greater the voltage drop. The smaller the wire gauge, the greater the voltage drop. The higher the current flowing through the wire, the greater the voltage drop. Copper wire has a lower voltage drop than aluminum wire. The higher the temperature of the wire, the greater the voltage drop. There are several ways to reduce voltage drop, including using larger wire gauges, shortening the length of the wire, reducing the current flowing through the wire, using copper wire instead of aluminum wire, and keeping the wire cool. Voltage drop can be calculated using Ohm's law. Ohm's law states that voltage drop is equal to the current multiplied by the resistance. The resistance of a wire can be calculated using the following formula: R equals ρ times L divided by A, where R is the resistance in ohms, ρ is the resistivity of the wire in ohm meters, L is the length of the wire in meters, and is the cross-sectional area of the wire in square meters. There are also voltage drop calculators available online that can be used to calculate voltage drop. The National Electrical Code, or NEC, provides guidelines for acceptable voltage drop in electrical circuits. The NEC recommends that the voltage drop in branch circuits should not exceed 3%, and the voltage drop in feeder circuits should not exceed 5%. It is important to note that these are just recommendations, and the actual acceptable voltage drop may vary depending on the application. For example, some equipment may be more sensitive to voltage drop than others. It is always best to consult the manufacturer's specifications for the equipment to determine the acceptable voltage drop. Here's a breakdown of how to approach the voltage drop calculation and mitigation for the well pump scenario. Firstly, understand the components. The well pump is an electrical load requiring a certain voltage and current to operate correctly. The wiring is the conductor carrying electricity from the power source to the pump. Voltage drop is the loss of voltage along the wiring due to its resistance. Secondly, identify the critical factors. The distance from the power source to the pump significantly impacts voltage drop. Longer distances mean more resistance and thus more voltage drop. The wire gauge determines the wire's current carrying capacity and resistance. Smaller gauges have higher resistance. The pump's current draw is the amount of electricity it needs to operate. Higher current draw increases voltage drop. The acceptable voltage drop is the maximum amount of voltage loss the pump can tolerate without performance issues. Thirdly, calculate the voltage drop. You can use a voltage drop calculator or formula to estimate the voltage drop based on the factors above. The formula is voltage drop equals 2 times length times current times resistance per 1000 feet divided by 1000. The length is the one-way distance in feet. The current is the amperage of the load. The resistance per 1000 feet can be found in NEC Chapter 9 Table 8 for different wire sizes. Fourthly, analyze the results. Compare the calculated voltage drop to the acceptable voltage drop. If the calculated voltage drop exceeds the acceptable limit, you need to take corrective action. Fifthly, consider mitigation strategies. One strategy is to increase the wire gauge. Using a larger gauge wire reduces resistance and thus voltage drop. Another strategy is to use a 240-volt service. This reduces the current required for the same power, which in turn reduces voltage drop. You could also shorten the wire run if possible, although this is usually not practical for a well. Sixthly, consider other factors. Always use appropriate wiring methods, such as running the wires in conduit for physical protection. Ensure proper grounding for safety. Install a correctly sized circuit breaker to protect the circuit from overloads. Seventhly, follow NEC guidelines. The NEC provides recommendations for voltage drop in branch circuits and feeders. Adhering to these guidelines helps ensure safe and reliable operation. The NEC recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders. In summary, carefully calculate voltage drop, compare it to acceptable limits, and implement appropriate mitigation strategies to ensure the well pump receives adequate voltage for reliable operation and longevity. Always prioritize safety and follow electrical codes. Now let's talk about choosing the right wire. When selecting wire for a well pump, several factors must be considered to ensure safe and efficient operation. Firstly, determine the appropriate wire gauge. The wire gauge must be sized to handle the pump's current draw and minimize voltage drop. Voltage drop occurs when the voltage at the pump is less than the voltage at the power source due to the resistance of the wire. Excessive voltage drop can cause the pump to run inefficiently and shorten its lifespan. Secondly, consider the type of wire. The most common types of wire used for well pumps are copper and aluminum. Copper is a better conductor than aluminum, so it has a lower voltage drop. However, copper is also more expensive than aluminum. The type of wire to use will depend on the specific application and budget. Thirdly, select the appropriate insulation. The insulation on the wire must be rated for the environment in which it will be used. For example, if the wire will be exposed to moisture, it must be insulated with a waterproof material. The insulation must also be rated for the voltage and current that the wire will be carrying. Fourthly, follow the National Electrical Code, the NEC. The NEC provides guidelines for the installation of electrical wiring. These guidelines must be followed to ensure that the wiring is installed safely and correctly. Some specific NEC requirements for well pumps include grounding, overcurrent protection, and wiring methods. Fifthly, calculate voltage drop. The voltage drop can be calculated using a voltage drop calculator or by hand using Ohm's law. The voltage drop should be less than 3% for branch circuits and less than 5% for feeders. If the voltage drop is too high, the wire gauge must be increased. Sixthly, consider the environment. The environment in which the wire will be used can affect the type of wire that is selected. For example, if the wire will be exposed to corrosive chemicals, it must be made of a corrosion-resistant material. The environment can also affect the ampacity of the wire. The ampacity of a wire is the amount of current that it can safely carry. The ampacity of a wire decreases as the temperature increases. Seventhly, consult a qualified electrician. If you are not familiar with electrical wiring, it is best to consult a qualified electrician. An electrician can help you select the appropriate wire for your application and install it safely and correctly. Choosing the right wire for a well pump is critical for safety and performance. Consider the wire gauge, type of wire, insulation, NEC requirements, voltage drop, and environment to ensure the pump operates efficiently and reliably. Let's delve into the specifics of 240 volts versus 120 volts service for a well pump. The choice between 240 volts and 120 volts service for a well pump depends on several factors, including the pump's horsepower, distance from the power source, and acceptable voltage drop. Firstly, consider the pump's horsepower. Higher horsepower pumps typically require 240 volt service. This is because they draw more current, and using 240 volts reduces the amperage, minimizing voltage drop over long distances. Secondly, consider the distance from the power source. For longer distances, 240 volt service is generally preferred. As mentioned earlier, higher voltage reduces current, which in turn reduces voltage drop. Thirdly, consider the acceptable voltage drop. Calculate the voltage drop for both 120 volts and 240 volt service to determine which option meets the acceptable voltage drop requirements. Remember, excessive voltage drop can damage the pump and reduce its efficiency. Fourthly, consider the wiring requirements. 240 volt service requires a 3-wire circuit, including 2 hot wires and a neutral wire. 120 volt service only requires a 2-wire circuit, including 1 hot wire and a neutral wire. This difference in wiring can impact the cost of installation. Fifthly, consider the cost. 240 volt service may require additional equipment, such as a 240 volt circuit breaker and a 240 volts receptacle. This can increase the overall cost of the installation. Sixthly, consider the safety. Both 120 volts and 240 volt service are safe when installed correctly. However, it is important to follow all applicable electrical codes and safety precautions. Seventhly, consult a qualified electrician. If you are unsure which voltage service is best for your well pump, consult a qualified electrician. They can assess your specific needs and recommend the best option. Here is a detailed comparison. 120 volts service is simpler to wire, typically using a 2-wire circuit. It's often less expensive upfront due to fewer components. However, it results in higher current draw for the same power, leading to greater voltage drop, especially over long distances. It may be suitable for low horsepower pumps close to the power source. 240 volt service requires a 3-wire circuit and may have higher initial costs. It results in lower current draw, minimizing voltage drop over long distances. It's generally recommended for higher horsepower pumps or when the pump is located far from the power source. It provides more efficient power delivery and can extend the lifespan of the pump. In conclusion, weigh the pros and cons of each option based on your specific circumstances. Consider the pump's horsepower, distance, voltage drop requirements, wiring costs, and safety. Consulting with a qualified electrician is always recommended to ensure safe and efficient installation. Now let's consider grounding, which is absolutely critical. Grounding is an essential safety measure for well pumps and all electrical systems. It provides a low resistance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Here's why grounding is so important. Firstly, safety. Grounding protects people from electrical shock by providing a path for fault current to flow back to the source. If a fault occurs, such as a wire coming loose and touching the metal casing of the pump, the grounding system will trip the circuit breaker, cutting off the power and preventing someone from getting shocked. Secondly, equipment protection. Grounding protects equipment from damage caused by electrical surges and faults. Surges can damage sensitive electronic components, and grounding provides a path for the surge to dissipate safely. Thirdly, code compliance. Electrical codes require grounding for all electrical systems. This is because grounding is a proven safety measure that has been shown to prevent electrical shock and equipment damage. Here's how grounding works. The grounding system consists of a grounding electrode, such as a ground rod or a metal water pipe that is connected to the electrical system. The grounding electrode provides a connection to the earth, which is a large reservoir of electrons. When a fault occurs, the fault current flows through the grounding system back to the source. This causes the circuit breaker to trip, cutting off the power. Here are some specific grounding requirements for well pumps. The metal casing of the well pump must be grounded. This can be done by connecting a grounding wire to the casing and running it back to the grounding electrode at the service panel. The grounding wire must be sized according to the NEC. The grounding wire must be protected from physical damage. The grounding electrode must be properly installed. Here are some common grounding mistakes to avoid. Not grounding the metal casing of the well pump. Using the wrong size grounding wire. Not protecting the grounding wire from physical damage. Not properly installing the grounding electrode. In conclusion, grounding is a critical safety measure for well pumps. It protects people from electrical shock, protects equipment from damage, and is required by electrical codes. Always follow all applicable electrical codes and safety precautions when grounding a well pump. If you are unsure about any aspect of grounding, consult a qualified electrician. Now let's consider the necessity of conduit. Using conduit for well pump wiring offers significant protection and safety advantages. Conduit is a protective tube or channel that encloses electrical wiring, shielding it from physical damage, moisture, and other environmental factors. Here's why conduit is highly recommended for well pump installations. Firstly, physical protection. Conduit protects the wiring from damage caused by rocks, roots, rodents, and other physical hazards. This is especially important for underground wiring, where the risk of damage is higher. Secondly, moisture protection. Conduit helps to protect the wiring from moisture, which can cause corrosion and electrical shorts. This is particularly important in wet or damp environments. Thirdly, safety. Conduit provides an additional layer of safety by containing any potential electrical faults. If a wire becomes damaged and shorts to the conduit will provide a path for the fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Fourthly, code compliance. Electrical codes often require the use of conduit in certain applications, such as underground wiring and wiring in wet locations. Here are some common types of conduit. Rigid metal conduit, or RMC, is a heavy-duty conduit made of steel or aluminum. It provides excellent physical protection and is suitable for both above-ground and underground applications. Intermediate metal conduit, or IMC, is a lighter-weight version of RMC. It provides good physical protection and is also suitable for both above-ground and underground applications. Electrical metallic tubing, or INT, is a thin-walled conduit made of steel or aluminum. It is lighter and less expensive than RMC and INC, but it does not provide as much physical protection. It is typically used for above-ground applications. Flexible metal conduit, or FMC, is a flexible conduit made of steel or aluminum. It is used to protect wiring in tight spaces or where flexibility is required. Non-metallic conduit, such as PVC conduit, is a plastic conduit that is resistant to corrosion. It is often used in underground applications and in wet locations. Here are some tips for installing conduit. Use the correct size conduit for the wiring. Secure the conduit properly to prevent it from moving or being damaged. Seal the ends of the conduit to prevent moisture from entering. Follow all applicable electrical codes and safety precautions. In conclusion, using conduit for well pump wiring provides significant protection and safety advantages. It protects the wiring from physical damage, moisture, and other environmental factors. It also provides an additional layer of safety by containing any potential electrical faults. Always follow all applicable electrical codes and safety precautions when installing conduit. Finally, let's discuss circuit breakers. A circuit breaker is a safety device that protects electrical circuits from overloads and short circuits. It is an essential component of any electrical system, including well pump circuits. Here's how a circuit breaker works. A circuit breaker consists of a bimetallic strip or an electromagnet that is designed to trip when the current exceeds a certain level. When the current exceeds the rated amperage of the circuit breaker, the bimetallic strip heats up and bends, or the electromagnet pulls a lever, causing the circuit breaker to trip and interrupt the flow of electricity. This protects the wiring and equipment from damage caused by excessive current. Here's why circuit breakers are so important. Firstly, overload protection. Circuit breakers protect against overloads, which occur when too much current is flowing through a circuit. This can happen when too many appliances are plugged into the same circuit, or when there is a fault in an appliance. Secondly, short circuit protection. Circuit breakers protect against short circuits, which occur when there is a direct connection between two wires that are supposed to be insulated from each other. This can happen when a wire becomes damaged or when there is a fault in an appliance. Thirdly, fire prevention. Circuit breakers help to prevent fires by interrupting the flow of electricity in the event of an overload or short circuit. This prevents the wiring from overheating and potentially causing a fire. Fourthly, code compliance. Electrical codes require the use of circuit breakers in all electrical systems. This is because circuit breakers are a proven safety measure that has been shown to prevent electrical shock and fires. Here are some tips for selecting the right circuit breaker. Choose the correct amperage rating for the circuit. The amperage rating of the circuit breaker should match the ampacity of the wiring. Consider the inrush current of the well pump. Well pumps typically have a high inrush current when they start up. The circuit breaker should be sized to handle this inrush current. Choose a circuit breaker that is compatible with the electrical panel. Follow all applicable electrical codes and safety precautions. Here are some common circuit breaker mistakes to avoid. Using the wrong size circuit breaker. Overloading a circuit. Tampering with a circuit breaker. Not replacing a damaged circuit breaker. In conclusion, a circuit breaker is an essential safety device that protects electrical circuits from overloads and short circuits. It helps to prevent fires and electrical shock. Always follow all applicable electrical codes and safety precautions when selecting and installing circuit breakers. If you are unsure about any aspect of circuit breakers, consult a qualified electrician. By understanding these various aspects of voltage drop, wiring, and safety devices, you can reliably get power to the well.